Let's have a look at what to do when we are going to factorize our exponents. Now, example number 3 is found on page 36. It's got an A and a B. We're going to start with question A, which I've written out for you, but also I've written out the basic laws of exponents on the right-hand side. And this is important because this is what we're going to use as our reference. So what you'll see on our fraction is we've got 3 to the power of x plus 1 plus 2 times 3 to the power of x plus 2 divided by 7 times 3 to the power of x. What I want you to notice is you have these strings on the numerator, and these strings are part of the first law of exponents. And in today's exercise, you are going to go that way for me. So instead of stringing, you are going to break it up into separate pieces for me. This means that our first item is going to be 3 to the power of x multiplied by 3 to the power of 1. Reason is because if I'm adding the exponents, it means I'm multiplying by the same base with separate exponents. Now I'm bringing down that plus, and I'm bringing down the 2. The 3 with the yellow highlighted exponents, we're going to split into 2, same base, one with an x, one with a 2, and I'm multiplying them. Then I'm going to divide 7 times 3 to the x, and the only thing that we did here was we split those 2 and we split those 2. Everything else remains the same. Okay, awesome. Now that we've done this, I'm going to ask you my favorite question, which the answer is going to be wrong, but let me ask it so that the answer is right. In the numerator, how many terms do you have? In the numerator, we have 2 terms. So in the numerator, we can take out the highest common factor. Remember that the whole fraction is only 1 term. But if we're only upstairs we've got 2 terms. Now, can you take out a highest common factor upstairs? Let's see what both groups have. This one has a 3 to the power of x, and this one has a 3 to the power of x. So upstairs, I can take out 3 to the power of x. So that's out. It's outside, right? Now, upstairs, I've got 3 to the power of 1 and 3 to the power of 2. Those are or are not the same? Are they or are they not? So 3 to the power of 1 is 3, and 3 to the power of 2 is 9. No, they're not the same. Okay, so we're not going to take anything out there. In my first group, I'm done. There's nothing else to check. So there's nothing else to check. So now, because I took one out, I have brackets. We remember this from factorization. What's left in the bracket? I took out 3x. I'm left with 3(1) plus 2 multiplied by 3 squared. The denominator, I have 7 multiplied by 3x. Beautiful. Now, what's the relationship between this 3 to the power of x and the bracket? That's multiplication, which means that this whole thing here is one term now. And because it's multiplication and division, I can now cancel. So 3x divided by 3x is equal to 1 over 1. Beautiful. Okay, I have gotten rid of all my x's. Now I've got 3 to the power of 1 is just 3, plus 2 times 3 squared, which is 9, divided by 7. Using BODMAS, I have to do multiplication first, right? So that means I have 3 plus 9 times 2 is 18, divided by 7. And now, quick question. Are we going to deal with 3 plus 18 first, or are we going to deal with 3 divided by 7 plus 18, or 3 divided by 7 plus 18 divided by 7? So remember that when you are doing fractions, the numerator is in invisible brackets and the denominator is in invisible brackets. So brackets actually come first. In these brackets, we did 2 times 9. But the important thing is that you must simplify above and you simplify below. Okay, so what is 3 plus 18? That's going to give you 21 divided by 7, and that gives you an answer of 3. So this entire fraction simplifies to 3. That is how you do question A.